if I just have these 2 points, what will I conclude? I just conclude 0 all the way, right? I wouldn't know what's in the middle. Okay? So, what's the next best? If I take 3 samples, 1 more in the middle, still cannot. No, okay, you should understand this formula. Okay, I'm trying to explain how to use the formula. First of all, this capital T is the period of the sine wave that I have. Okay, so this is capital T, right? Okay, time taken for one complete wave is the period. So just now I had 2 points. That means my sampling period is the same as the period of the sine wave. No use. Okay. Then I tried half. Okay, if it's T over 2, also no use because I get 3 points all at the 0 line. I just assume it's 0. So what's the next thing that I can do?
1/4.
1/4. So if 1/4, where will my points be?
There, middle, in between.
Actually, I still have the first and the last. Okay. Then my in between, I'm going to have something here. Okay, another one here. Okay. So everything T over 4. Is this considered T over 4? T over 4. T over 4. Okay. Actually, you could choose T over 3 as well. Okay. That will also give you some in between points. Okay. So basically, what this rule is saying, T over 2. Just now we tried T over 2. It's useless. Okay. It's the worst sampling period I can take. I mean, even though I put here equals to, it's like, you shouldn't do it. It's like the absolute worst sampling period I can have because you will not be able to get the graph back. The best is T over 4. Of course, there's an in between T over 3 in between. You can use that as well. So this is giving you a range of sampling period that you can take in order to be able to reconstruct the sine wave. Okay? So the thing that you need to bear in mind is that the value here is always the worst. Okay, the value here is the best. Because we always want the sampling period to be as small as possible, okay? But not too small such that it is useless. Okay, so we want to find the best. Okay, the best will be, of course, if you have enough data storage, you can choose the best. Okay, the worst is, okay, if really no choice, I want the bare minimum to get back the graph, okay, it should be T over 2. So that's how you interpret this inequality. So anything within this range is a good sampling period that will help you to get back the graph, okay? At least with some significant accuracy. Any questions so far? So how will I ask such a question in the exam? How to use this formula? I tell you what, let me finish all the rules, then I go through the question. That will be easier. Okay, so that you know when to use what. Because that will be the biggest confusion of this chapter. Okay, let's go on to the second rule. Okay, the second rule is that if now if your signal is not a sine wave, okay? The first one was if it's a sine wave, use that. Okay, now if it's not a sine wave, then I have the second rule. The sampling period can be chosen such that there are 2 to 4 samples taken per rise time. Okay. So, when or what kind of graph can this rule be applicable? When did you last hear about the rise time? Which chapter was that? Yours? Rise time come for what kind of graph? Underdamped. Okay, so the underdamped graph looks something like that, with overshoot, right? So what is the definition of rise time? I've got it already. The first moment that your graph hits the steady state value, right? So this is the rise time. So now what this rule says is that, let's say you don't have a sine wave. This is not a sine wave, okay? So your sine wave must be clearly repeating and with the same amplitude. This is not a sine wave. Yes, at the start you got some sort of sine wave, but it decays. So for this kind of graph, how to find the settling time? So what they say is, The worst is to have just 2 samples per rise time. So if I say 2 samples per rise time, this is the worst by 2 black dots. So it's still not too bad because I can still draw a straight line connecting the two of them. Okay. What is the best? I have 4 samples by the rise time. Okay, so which would mean my rise time divided by 4. So this is my TR over 4, right? So every point, okay, and get a sample, I'll be able to sort of get the graph back with the blue crosses because it's somewhat closer to the black graph, right? Okay, so this range is for these sort of graphs, okay, where you do not have a sine wave, okay, but some sort of a underdamped response, okay. If you can find the rise time, use the rise time to decide your sampling period. Any questions? So bear in mind, when can you find the rise time? Only for underdamped. That means only when zeta is less than 1. If zeta more than 1, there's no way you can find rise time. Okay? Now let me move on to the third one. Okay, third one is more on the dominant time constant. Okay? So dominant time constant comes into the picture only for overdamp. Okay, so that is when zeta is greater than 1. Why are we concerned about dominant time constant? Okay, because dominant time constant is the one that decides the speed of your graph. Okay, so that's why we use that instead of the other time constant. So the definition, okay, it has been already defined. It's going to be 1/10 of that. So there is no range here. This one is fixed. You just take 1/10 of the dominant time constant. Okay, then you should be able to get the graph back. Okay, so I just give a very quick example. Okay, so if I have, let's say, overdamp response. So overdamp response has no overshoot, so it slowly goes to steady state value, and normally the settling time is 5 times tau d. Okay, that means which means my tau d can be somewhere here. So now my sampling period is going to be 1/10, so that means it's going to be every moment you're going to measure, okay, which is more than enough, okay, because you will be able to capture all the points by the time it settles down. Okay, so don't worry about the derivation as why is 1/10. It's going to be 1/10. You just have to use the result. Okay, we are not looking at how they come to the 1/10 tau d. What we are just using is just applying it and choosing the right sampling period. Okay, so lastly, the last one, which is the most complicated formula. Okay, this definition has been reworded into this formula. Okay, please just remember one of it. Don't go and write down this and confuse yourself, because this is angular frequency, sampling frequency, not sampling period. Okay, I have rewritten it as in the formula as sampling period. Okay, so this is based on the Nyquist criterion as well. Okay, as I said, let me not go into details of the derivation now. So you're supposed to use the range. This one is back to the range. Again, this one on my left hand side is the worst possible TS, and the best. The one on the right hand side is the worst. Okay, and this is only applicable when zeta is less than 1. Okay, why? Because you got square root 1 minus zeta squared. If zeta bigger than 1, you cannot evaluate this. Okay, so please take note of the condition so that you know when to use what. Okay, now let me come to how to actually use all this, okay, based on the tutorial questions, or which are actually your exam questions as well. Okay, I'll be using tutorial 5 questions, so if you have the questions with you, please refer to them. If not, I can just show the questions here. Okay, so tutorial 5, let's look at, okay, let's look at question 8 first. Question 8, right at the end of tutorial 5. 8A only. If you do not have it, just refer to I'm doing here. Okay, so you are given the plant or a system. Okay. So what you are asked to find is a characteristic equation. Okay, that's the first part. We are more concerned about second. How to suggest a suitable sampling period for this system. Let's say I'm going to use this system with a digital controller. That means you're going to have a controller for this guy. How to decide what the sampling period should be? Is there a sine wave here? Can it be the rule number 1? You don't even know what input is. Okay. How about rule number 2? Do we know whether it's under them or over them? You can use the actually the part 1 leads the answer to part 2. Okay, the characteristic equation is there to help you find something. Find what? If you look at the rule, after the first rule, the remaining 3 is dependent on zeta. If you know zeta, you know what to use. So that's the easiest to find this. If zeta is less than 1, you know it's 2 and 4. If more than 1 is 3. Okay? So, can we find the zeta for this? So, how to find the zeta? You need to divide by 2 first before you equate. So, to the standard equation. Okay, please remember to divide by 2. Okay, at this stage, don't go and do this mistake. Forget to divide by 2. Okay, so your omega n is going to be square root 1.5. And what is the zeta? Is it less than 1 or more than 1?
More than 1.
3.5 over 2 square root 1.5. More than 1? What's the value? Nobody wants to press. 1 point? Okay, so it's greater than 1. So which rule to use? 3. So 3 says that 1 over 10 tau d. So now, how to find the tau d? Before the common test, I gave a very quick way to find tau. What is it? What do you need to do to this? There's 2 tau there, and we need to find the bigger one to know which one is tau. What's the easiest way to find the 2 tau? First of all, you need to factorize this. Don't need to go to partial fraction. That is the whole deal for this. Okay? Just factorize. If I factorize this, what are my terms? Something and s plus something. What's the two terms? Everybody can find this? Okay, so once I have it in this term, what are my 2 tau? How to find? Remember, I thought I did, but I'm not sure whether you all can remember already. Okay, anyway, if you have this kind of factorized term, make sure your factorized term is of this form. Okay? It must be of this form. Sorry, this is not t, it's tau. Okay? So if it's of that form, then the number beside the s is the tau. Okay? So in that case, I can easily find one of it, which is 2. Okay, because this guy is in the correct form. How about the other one?
1 over 10.
Yeah, so 1/3. So which one is the bigger tau between the 2? So my tau d is 2 seconds, which translates to my sampling period of 2 over 10, which is 0.2 seconds. So if I use 0.2 seconds for this system, it's enough. There will not be any reconstruction error. Okay, it's It's not too big or it's not too small. It's just nice to get capture all the important points. Any questions? Do I have to repeat this again? Any part that I have to repeat? First step is to identify what rule to use. Once you know the rule, then to use the rule to get the answer is another marks. Okay, so that's basically how we give you the marks. Actually, the mark can be quite high, because the fact that you need to decide this rule is itself, I will give you the mark. Okay, because you need to know which one of the four. Okay, so please try to get it. Okay, the effort is minimal because once you know the rule is after that it's just simple division. Okay, there's no Laplace or partial fraction here. Okay, it's just find the tau and then divide. Okay, so that's one rule that we use. If you go up to question 7, same kind of question. Suggest a suitable sampling period. Now, what are you given? You're not given the plant. Okay, what you're given is the graph. So the graph is what kind of graph? Under that. Okay, because the whole should there. So how to suggest the sampling period? Definitely rule 1 cannot, it's not a sine wave, right? So which rule can I use? Rule 2? So what does rule 2 do? Everybody agrees there has to be rule 2. Do you think that it could be 3 or 4? 4 can also, but the thing is for 4, because zeta is less than 1, you know for sure. Okay? So it can be rule 2 or 4. But for 4, what do you need to know? To be able to use 4, what do you need to know? You need omega n, you need zeta for 4. Do we know all this here? You don't know. You can only find if you know the transfer function, which you don't know. Okay, so rule 2 says TR over 4 TS TR over 2. So how to find the TR from this given question? Where's the TR here? Got a few time labeled there. No? Which one to use? Okay, 1, 2, 3. Which one to use? 1 is 0.61, which is here. Okay, 1.16 is my point number 2, which is here. And 3.7 is here. Yes. Okay. This kind of graphs on a paper, you can never go and read off value yourself. I must give you the value there, and you have to use the values that I gave. So I gave 3 there. Which one to use? So 0.61 is the rise time. 1.16 is the peak time. Okay, and 3.7 is actually the settling time. So you must know the definition correctly. So in this case, it's 0.61 over 4. So your sampling period should be in between this range. For this question, you can either give a range or you can just give me this, a suitable sampling period as this, the best. I mean, because when you suggest, you usually should suggest the best, okay, unless I ask you for the worst. Okay, so the range also is an acceptable answer, or just this is also an acceptable answer. Okay? Any questions? Yep.
Is it explain your choice you have to write now? Like you usually write
The explain your choice is basically the choice of the rule.
So just write now, don't need explain
No need to explain. Okay, as long as you get the rule right, okay, then basically you just continue your working. No, because you know what, the explain your choice comes there. If you just give me TS equals to 2 seconds, just the answer like that, I cannot give the marks even if the values happen to be correct. Okay, so it's just for that sake. So you need to identify the rule and then get the number. Get the numerical answer. Can I do one more before I go back to the lecture? Okay. Question 6A. 6A. No, right? And then they give you the equation of the sine wave. So what's the maximum sampling period? Okay, so first one says that for sine wave, the range is t over 4, okay, ts, t over 2. When they ask for maximum, which one should I use, t over 4 or t over 2? Yes, so this one they're asking for maximum is the worst. Okay, that's why I said sometimes I can ask you for the worst. Okay, not the best. So ts, you know you have to go out and find t over 2. How to find the capital T? So the first step is to identify the rule. The next step is to identify what the question is asking in that rule, right? Okay, it's asking for the worst. Okay, which is the right-hand side of your inequality range. Then, how to find the capital T? This number 2 are very important. What is it? This is omega, right? So omega, how is it related to capital T? Omega is 2 pi over T, okay, or is 2 pi F, okay, all these relationships also must be in your cheat sheet, please. Okay, so if I know omega is equals to 2, what is my T? Can I find my T? From here. So capital T is going to be 2 pi over 2, which is just pi. Pi is 3.14, okay, 3.14 seconds. Okay, so it's just another way of writing 3.14 seconds. So now this T over 2, so it's going to be 3.14 seconds over 2. So my sampling period is just 1.57 seconds. Okay? Shall I continue and finish at 12:30 or give break? Break. Okay, so please come back at 12. How many one break? Only one break, ah? So the rest say continue, I continue, is it? Hey, what you want?
Going for break already.
Yeah, then have to break already, then too slow already. Bye. So please come back at 12. Give me the attendance list.
Sorry, mommy.